Good morning, guys. Am I audible to all of you?
Good morning, sir.
Very good morning.
Good morning, sir.
And my screen is also visible to all of you, right?
Yes,
Okay. Let's start today's session. In our previous session, we have discussed two important concepts. One is log and another one is monitor. And we discussed how to use log to provide thread safety. And we have also discussed how to use monitor class static methods to provide thread safety, right? And we have discussed that using log, the restriction is there. That means you cannot achieve that signaling mechanism, right? If you want two threads to communicate internally, right? That is not possible using log. And if you want two threads to communicate, right, inter-thread communication, then in that case you need to use monitor class. There is something called uh, signal method and sorry, there is something called pulse method and there is something called wait method. By using pulse and wait, you can implement signaling mechanism where you will allow two threads to communicate simultaneously, right? So that is what we have discussed in our yesterday session. Today we are going to continue our multi-threading thread synchronization uh, concept, right? Today we are going to discuss mutex, right? So before understanding mutex class, right? First of all, we have to understand we have already lock and monitor class who will provide thread safety to our shared resources in a multi-threaded environment. Then why mutex class, right? Already you have log mechanism, already you have monitor mechanism, then why you should learn mutex, right? That should be the question, right? So in interview they might be ask you this question, why we have already log and monitor which will provide thread safety, then what is the need of a mutex class? Or they will ask you the question other way, that when we need to use mutex class in multi-threading, right? That first of all, we need to understand why we need mutex. Then we will understand what is mutex and how to use mutex in .NET applications, right? So let us understand the definition. Mutex also helps us to ensure that our code is thread safe. That means like the monitor and like the log, Mutex also provide thread safety to our code in a multi-threaded environment, right? That means when we run our code in a multi-threaded environment, then we do not end up with inconsistent result or inconsistent behavior, right? So if you are using Mutex class to implement thread safety, then also you will not get any inconsistent output. You will not get any inconsistent behavior. You will get the expected output, right? The log and monitor, right? Log and monitor ensure thread safety for threads that are in process. In process, what do you mean by in process thread? The in process thread means the thread which are generated by the application itself, or you can say internal threads, right? The example what we have discussed in our application so far, right? The main thread is the out of process thread, because main thread is not generated by our application code. In our application code, by using the thread class, whatever thread we generated, those are nothing but our in process thread, or you can say internal thread. But do we have write any threading class to create the main thread?
No.
That means main thread is not our internal thread. Internal thread means in our code, the thread which we created, they are called as internal threads, right? But the thread which is provided by the operating system, right? Those thread are said to be external thread or out of process thread, or provided by some outsider. And the main thread is example of out of process thread or external thread. And the thread what we created in our application, those are called as internal thread, right? And the lock and monitor, these two mechanisms provide thread safety for internal thread only. What do you mean by this? Now the thread which we created to run to execute our code, right? Those thread safety will be provided by lock and monitor class. If one thread is coming from outside of our application code, right? Then they will not provide thread safety to them. Whereas mutex ensure thread safety for threads that are out of process, right? That means if you want to restrict, right? If some thread is provided by some external application and you want to restrict that your code should not be accessed by multiple or more than one external thread at the same time or concurrently, right? Then you need to use this mutex class, right? See this example. Suppose this is your code. This code block is nothing but you can consider this is your shared resources and multiple external threads trying to access your code. If multiple external threads trying to access your code, then you will see that only one thread can access your code, and while other threads will be there in the waiting list, right? Okay. To understand this, what I can do is I'm creating a simple example, right? In this example, you can say I have only written this piece of information, right? I have written this simple piece of information. What I'm doing, I'm building my solution, right? Build the solution. Go to the location where your exe file is generated, right? And double click on this. Once you double click on this, one thread will be allocated by the operating system, right, as part of the process. And that thread is going to run our application code. And that thread is nothing but our main thread, right? Now, if you go to the task manager, then you will see that threading demo, you can see this is my exe currently is running. And we already discussed that each application to run each application operating system will allocate one process, right? And to run this threading demo application, or you can say this exe file, operating system allocate one process, right? And you can see here in the application list, this is nothing but processes. One process is there to run this application, and as part of this process, we have already discussed there is something called a thread which will actually run our application code, right? And in this case, what is that thread? That thread is nothing but your main thread. Yes or no?
Yes, sir.
Okay, right. Fine. Now, what I'm doing, I'm again double clicking on this, right? That means currently, how many instances is running of our exe?
2 instances.
That means there should be two application. You can see two processes in this case. In this case, two processes means how many main thread is currently executing our application code?
2 minutes.
2 men.
Two main thread. That means if you want to restrict, right? These things you cannot restrict by using your log and a monitor, right? Because this main thread, what currently our executing our application code, right? That cannot be handled. That cannot be restricted by using the log and a monitor class, right? So situations like this, if you want to restrict that only one thread, only one external thread should execute our application code, while if more than one thread trying to execute our application code, we should not allow them. They should wait until the current thread which is running our application, current external thread which is running our application code once released, then only it should allow other threads to run our application. Then in situations like this, we need to use what? Mutex, right? Now, if you are still there, sir, can we achieve the same thing using log and monitor? No, you cannot achieve. Okay, to prove this, what I can do is, okay, let me copy the example code what we have written in our previous, right? So in this case, you can see, right? In this case, this is the example where we are using a log and a monitor, and you can see we are executing our application code, right? This application code is executed, right? Now, let me build the solution. In this example, I am using log enter and log exit, right? To log the resource and to release the log. So in this case, what I'm trying to do, I'm executing the exe file, right? I'm executing the exe file once. You can see the log is running. You can see executing another time. You can see executing another time. That means if you are implementing monitor and log, they only used to manage the internal threads, right? but they are not going to handle the external thread. You can see all the three external thread trying to execute our application code, and they are able to execute our application code. We do not want it. We want to restrict this. Then if you want to restrict this, then what you need to use? You need to use the Mutex class. How? Let me show this. Okay, let me first show you the example, and then we will try to understand the code, right? Don't go with the code what I am writing here, right? I'm just writing some piece of information, and you can see what it is going to show me. Now, if first time, if you are running first time you are running the application, this information is going to be display. Application is running, right? You have not closed this application. Again, you are trying to run the same application, or you are running the same exe multiple times. Then from the second time onwards, you will not get this message. Rather, you will get this information that an instance of the application is already running, right? And once you close this one, then you will again, if you click on the exe, then again you will see this message, right? Let me build the solution. Right now, one external thread is running our application code, and you can see application is running. Now I'm double clicking on this. See, I double click on this. In this case, after 5 seconds, right? Whatever time I have provided, 5 seconds. After 5 seconds, it is saying me that an instance of the application is already running, right? Again, I double click on the exe. Again, you will see after 5 seconds, again the same message is going to come. An instance of the application is already running. That means what? It means by using the Mutex class, we can restrict the number of external thread that can access our code. It will restrict only one external thread to access our application code. Then you might be have one question, sir, is it possible that we can restrict the number of external thread that can access our application code, like two external thread can access our application code, maximum of 5 external thread can access our application code? Yes, that is possible. That is we are going to also discuss after this Mutex, right? There is a class called Semaphore that we will discuss after this Mutex class, right? So you understand what is the use of a Mutex class, guys?
Yes.
Okay, now once you understand what is the use of a Mutex class and what we cannot achieve using a lock and monitor, right? Now let us try to understand the Mutex class in detail, right? Now, if you go to the definition of a Mutex class, then you will see that this is a sealed class. So as it is a sealed class, can we create a new derived class from this Mutex class?
No.
No, right? And as you can see, this Mutex class, it is providing some constructors, right? And we already know this is not a static class. That means if you want to access these methods, right, then what you need? You need to create an instance of this class or not?
Yes.
And to create an instance, what is required? Constructor is required, right? And in Mutex class, you can see there are many overloaded versions of the constructor. You can use any of the overloaded version to create an instance of the Mutex class, right? So you can create in a constructor using this one. You can create the constructor using this overloaded version, right? In this case, it is not taking any parameter. In this case, it is taking one Boolean parameter initially one. It means the caller thread is going to be the owner of the mutex object or not. If you are passing true, then the caller thread is going to be the owner of the mutex object. Or if you are passing false, then the caller thread is not the owner of the mutex object. In this case, it is taking another additional parameter. By using that parameter, you can provide one name to your mutex object, right? Right? And if you come to our application, then which one we are using in our code? Which version of the mutex constructor we are using? We are using this one, right? In this case, the caller thread means in this case, our main thread is not the owner of the mutex object, and we are providing one name that is mutex demo, right? If you don't want to provide this name, you can simply ignore this. That is also fine, right? So this is the version we are using. Apart from that, created a new, this will basically specify whether a new instance is created or not. That parameter will specify, right? That means if a new instance is created, then it will specify and that the parameter is created. I mean the mutex object is created. If false, it return false, then it will say that already one mutex object is created, so it is not creating. We'll see that how to use this open existing. What is this try open existing? We'll understand. And this nothing but your security. If you want to provide some security to your mutex object, then you need to use. But to be honest, in real time, we never used this concept mutex security, right? Even I have never used this parameter in any of my application, right? So basically, what we are going to use, you are going to use this overloaded version or this 3.1, right? Mostly, you will see any kind of application you develop, right? Any kind of application you develop, you mostly going to use these 3 overloaded versions, right? And you can see this mutex class, I'm using this constructor to create an instance. Once you create the instance, right, then you need to log the instance, right? So then how you will acquire a log? In this case, you can see to acquire a log, I'm using the wait1 method. But if you look at this class, there is no wait1 method. Is there any wait1 method?
No.
But using this mutex instance, I can access this wait1 method. Then can anybody tell me from where this wait1 method is coming?
Extension method.
Is there any extension method defined in our class? Can I access the parent class members using the child class object?
Yeah, I think it
Yes.
is from wait handle.
Exactly. This wait method is coming from the wait handle. If you go to the definition of wait handle, then you will see there is a wait1 method, right? And apart from that wait handle, it is also implement what interface?
IDispose.
And we have already discussed iDisposable pattern. That means once you use the object, then you need to call the dispose method to destroy the object, right? So basically, you can see here I'm calling this wait1 method, and this wait1 method actually trying to acquire a log on this mutex object, and if it acquire a log, then this wait1 method is going to return me true, and if it is not acquired a log, then it is going to return me false, right? And guys, remember, first time if you are calling this wait1 method, right, it is going to return us true. And if it is returning me true, then I'm not executing this piece of information, right? Because I'm using not operator. If it is returning true means it will become false in this case. This piece of information is not going to be executed, and it will execute these things. Second time you are invoking the application. Second time you are invoking the application means the mutex object is already logged by one external thread, right? That means for the second time, this method is going to return me true or false?
False.
False. But after 5 seconds, right? Because you have specified, it will try to acquire a log on this time period, right? If you go to the wait1 method, then you will see that it is taking one parameter milliseconds timeout and exit content, right? So this is Boolean parameter. If you are specifying true, false means in that period of time, if it is not acquired the log, then just complete and proceed. Don't wait forever, right? And you can also specify the timeout using the time span, right? And in this case, I'm using this 5 seconds. Even you can also use the time span, and you can set from seconds, and number of seconds you want, you can specify like this, right? That means within 5 seconds, if it is unable to acquire the log, right, then it is going to return me false. And once it return me false, then I'm using this not operator means this will become true. And once this becomes true, this piece of information is going to be executed. You can see this message is going to be printed, and here I'm writing this console.read line so that you can see the output, and once then it will return without executing the rest code in our application, right? So this is how the Mutex class work. So you have to create the instance, you have to call the wait1 method. This wait1 method is going to acquire a lock, right, on the external thread. Even and guys, it is not only acquiring lock on the external thread, even you can also use this mechanism to acquire lock for internal thread also, right? But the external thread, what lock this Mutex class providing, that cannot be achieved by using lock and monitor. Whatever functionality you are achieving using lock and monitor, you can achieve using the Mutex class. Plus the additional thing what you can achieve using Mutex class is it will restrict the external threads, right? It will restrict that only one external thread is going to execute your application. Is that clear?
So one doubt here, like when you're calling wait1 on mutex object, wait1 means like is it waiting?
No. It is not waiting. See, in our previous example, we have used mutex.enter method, right? What exactly the mutex.enter method does, it will try to acquire a log on the object, right?
I mean, you monitor.enter.
Yes, monitor.enter, right? So basically that enter method is trying to acquire a lock on the monitor object, right? So in this case, exactly the same thing is going to be done. If you go to the definition of wait1 method, block the current thread until the current instance receives a signal using a system time span to specify the time interval and specify whether to exit the synchronization domain before the wait, right? So that means what? Now it is going to wait for this seconds to acquire the lock, right? So it is going to be wait for 5 seconds to acquire the lock. In 5 seconds, if it is able to acquire the lock, then it is going to return me true, else it is going to return me false, right?
Okay, then what is the this false parameter that you are writing right
See,
here?
okay, so exit content now. So once you have a return false, then do you want to return from here only? Yes, I want to return here only. So I'm specifying this return statement. So this Boolean statement basically specifying that whether you want to exit from here or not. Right? So if you go to the definition, right? So you can see exit content. So in exit content, always try to go to the definition and try to read what is this exit content in the definition only. You can see true to exit the synchronization domain for the context before the wait. No, I don't want to exit before the wait. Once the wait is completed, then only I want to exit. This is the reason why I'm passing false. If I'm passing true, it will exit the synchronization domain for the context before the wait. But I don't want to exit before the wait. I want to exit after the wait time is completed. This is the reason why I'm passing this parameter as false. Right? See, anytime any parameter, see, if you go to the definition of what is the use of the parameter, right? Any, see, you can say initially on, right? This parameter. If you want to know what is this parameter, you can say this is a Boolean parameter. That means if I need to pass true or false. But what is the meaning of a true and false? That you can see by using by going to the definition. Then it will give you the definition, right? What is the meaning of that parameter? True to give the calling thread initial ownership of the mutex, otherwise false. That means if you want that the thread which is initially running our mutex object, if you want to give the ownership to that thread, then you need to use the parameter true. Else, by default, it is going to be false. Right? So in this case, which thread is C? In this case, multiple main thread is going to access our application code. Right? So if you are trying to access if you are trying to access your application code using by clicking the exe file 3 times, that means three main thread is going to access your application code. But in this case, do you want to provide the ownership to the first ownership to the thread which is calling your application. No, I don't want to provide the ownership. Yes, then make this parameter as false. Yes, I want to provide the ownership to the calling thread. Then you need to provide the parameter as true. But there is no difference whether you provide the ownership or not. There is no difference. Right?
Like in the new mutex, that parameter I was about to ask that if it
Sorry?
is true in the mutex, yeah, the first parameter false. So if it
Yes.
is true, it will allow the executing external thread to take over the uh,
See, in this case, I'm making this parameter as true, right? I'm building the solution. Okay, still the application is running. Okay, let me close this. So build succeeded. Okay. Okay, guys, there is an option called clean solution, build solution, rebuild solution. Can anybody tell me? I'm coming to that parameter, right? Can anybody tell me what is the difference between these three options?
build means you're converting your code into assembly, and if it is already built, if any changes, then you need to rebuild it.
Right.
And clean,
So clean solution means it will not generate the DLL, right? What you can see, right? So clean means it will clean the solution. Then you need to build the solution, right? And once you build the solution, then you will see the exe file, right? Let me clean the solution, right? And if you go to the debug bin, debug, you can see there is no DLL, right? Because I have cleaned the solution. Now what I'm trying to do is I'm going to build the solution. Once I build the solution, then you will see the DLL is generated, right? That means your application is compiled. Once you compiled, you can see the bytecode. Oh, sorry, bytecode. I'm saying you can see the intermediate language code. But once you clean the solution, then you will see that what DLL is generated, that is gone, right? So this is the one thing. And what is this rebuild means, right? Rebuild means it is first of all clean the solution, then build the solution. The combination of a clean solution and build solution is nothing but your rebuild. So once I rebuild, it will first clean the solution, then it will build the solution, and in that case, you can see the DL, right? So now what I'm trying to do is I'm going to run this application 3 times. See, application is running. See, there is no difference in program execution, right? You can say an instance of the application is already running. So what exactly this parameter specify means, the ownership is going to be the thread one. I mean the first thread, right? Who is initially create the instance is the owner of this object, right? And if you are passing false means there is no owner of this mutex object. Anyone can use this, right? So this is the thing that you need to remember, right? So in this example, I'm using this mutex class to create an instance or to manage the external thread. But when I'm going to use this mutex class to manage the internal thread, then at that time you will be able to understand this ownership concept, right? But there is no difference whether you pass this parameter as a true or false, right?
sorry,
And
as I understood, like if it is false, it will allow the first thread to run and take the ownership, and the subsequences ownership it will deny. Is it?
so,
Or it will
so
not?
see, there is no, is there any difference in the output? Whether you provide the parameter as true or whether you provide the parameter as false, is there any differences in the output? No. So ownership means what? Now, he is the owner of this resource, right? And if he is the owner of the resource, he can use the resource. And if there is no owner, then also he can use the resource. But in this case, there is no difference because whether he is the owner of the resource or not, once he is using the resource, then no one can use the resource, right? There is no difference in this example. right? Coming to your point, once we use the internal thread, then at that time you will get the clarity. But in this example, whether you are the owner of this resource or not, but once you are using this resource, then no one can use the resource, right? But in this case, you can see the first thread is got the ownership, but even that the second thread also going to use this resource, right? But for the second thread onwards, you can see first time it is going to create the object, right? But the second time onwards, it is not going to create the object. But even it is not going to create the object, but still it is going to call this wait one method. And in this case, this wait one method after 5 seconds is going to return me true, return me false. And the way we have written the logic, it will become true. And this piece of information is going to be executed. Right? There is no difference. Even if you don't use this one, then also it is going to be fine. Because you can see there is another overloaded version which doesn't take any parameter. Initial one means initially it won't. Later it is going to be changed. Right? But if you are not allowing anyone to be the owner of this, then that is also fine. This is optional. This is not mandatory. Right? And if you go to the Mutex class, then you will see apart from this, there are open existing, try open existing, then this release, Mutex, get access control, set access control, some methods, right? Let us try to observe those methods, right? So what is Mutex class? Mutex class also work like a lock. That is, it will also acquire an exclusive lock on a shared resource from concurrent access, right? But it work across multiple processes, right? The log and monitor, they work with internal thread, but this mutex class work with the across processes. That means if you are running your exe 3 times, that means 3 processes are there, right? You can see all the 3 processes in the tax manager. In this case, you can see 2 processes, and for each process there is 1 thread, right? To manage such threads, this mutex class is there. As you already discussed, exclusive locking is basically used to ensure that, see, we are saying exclusive lock, exclusive lock. What do we mean by this exclusive lock? Exclusive lock means only 1 thread can access the code at any given point in time. That is what, that is only 1 thread can enter into the critical section. When 2 or more threads needs to access a shared resource at the same time, the system needs a synchronization mechanism to ensure that only 1 thread at a time uses the resource, right? For example, if I'm not using this mutex class here, right? Then if I run this application 2 times, then both the thread is at the same time going to access the application code or not? Right? Suppose I'm writing this thing, right? Okay, let me close this one, right? Suppose I'm writing this thing and I'm using commenting this one, right? So after this change, right, and I build the solution, right? And I go to the ex file and I'm clicking this one. One external thread accessing the application code, right? I'm clicking another external thread accessing. So anytime I click, that means multiple threads accessing the shared resource at the same time or not?
Yes.
Good. Okay. So when 2 or more threads needs to access a shared resource at the same time, the system needs a synchronization mechanism to ensure that only 1 thread at a time use the resource, right? In this case, you can see multiple threads. In this case, you can see multiple threads accessing the shared resource at the same time. But we need to ensure that we need a synchronization mechanism which will ensure that only one thread can use the resource at the any given point of time. And for that reason, we are going to use mutex. So mutex is a synchronization mechanism that grants exclusive access to the shared resource to only one external thread. If a thread acquires a mutex, the second thread that wants to acquire that mutex is suspended until the first external thread release the mutex, right? So that is what we have seen, right? If you are using mutex, right? If you are using the mutex mechanism, then once it acquire one mutex, then the second thread which will trying to acquire the mutex object, they will suspend it until the first thread which acquire the mutex release the mutex. Until and unless he is not releasing the mutex, then no other thread can access the shared resource, right? That is what we have seen so far, right? Now, if you go to the constructor and method, we have discussed these are the different constructors available in our Mutex class. Apart from this constructor, you can see there are three important methods that we need to understand. What are these? One is open existing, another one is try open existing, another one is release mutex. These two are never used, and I never used these two, but I don't know how to use also these two methods because I never see any kind of example, and I never get a chance to set these things, right? But this thing we are generally or we majorly use this. We never use these two methods, right? So you can say this open existing means this method is used to open the specified named mutex if it is already exists, right? Suppose first you need to create one instance, and once you create one instance, on this instance you can call this open existing method, right? And once you call this open existing method, right, while creating the instance you are providing one name, so that while calling this method you have to provide the same name, right? And once you are calling the open existing method by providing the mutex name, right, then if that mutex is already created, then it is going to return as one mutex object, right? And if that object is not created, then it is going to return me null. How that practically we will see, right? It returns the object that represent the named mutex. Here the parameter name specify the name of the system mutex to open, name of the mutex to open. It will throw argument exception if the name is empty string or name is longer than 260 character. It will throw argument null exception if the name is null, right? That means while calling this open existing method, you have to provide the name. And if that name is null or empty, then it is going to throw you argument exception. And if the name is more than 260 character, then also it is going to throw me argument exception. And if the name is null, then this is going to throw me this argument null exception. That means how? So, and you can say this is a static method or non-static method.
Static one.
Then how to call the static method?
Using class.
Right? So you have to call like this, mutex dot open existing, right? And while calling this method, you have to provide this one, right? Right? And in this case, you have to write this within the try block only, right? Within the try block, you have to write like this, right? So what will happen? Now, it will try to open this instance, right? It will try to open the mutex whose name is this. If the mutex is existing, then it will return me one instance, right? What instance it is going to return me? Mutex instance, right? It is going to return me mutex instance. If this instance is not exist, then it will throw one error, and in that case, we need to create an instance here. Like this, we are going to use the mutex. So this open existing method, what exactly it is going to do is, it is going, practically we'll see the example. I'm just showing you the syntax, right? It will try to open one existing, forget about these things, right? So in this case, so when our application code is run, right? When our application code is run, first of all, this statement is going to execute, right? Okay, let me do one thing. Let me put this thing outside. Right? So this mutex.open existing method is trying to open the existing mutex instance, whose name is this. If this is not existing, right? If this mutex instance is not created, then in that case, it is going to throw me one exception. And in that case, this catch block will catch that exception. And in the catch block, we need to create the instance, right? And in this case, once we created this instance means one mutex object is created whose name is mutex demo. Second time you are running the application, second time this statement is going to be executed, right? And second time it is not going to throw you exception because this object is already created. So open existing means it is trying to it is opening one existing instance, right? There is opening one existing instance, right? If it is existing, then it is going to return that instance, and if it is not existing, then in that case it is going to throw me some exception, right? And there is another version, you can see try open existing. So in this case you can see it is returning mutex instance, and in this case what it is returning, it is returning boolean, right? So how you are going to use, so you have to use like this, try open existing. But in this case it is not going to return me this, right? What it is going to return me, it is going to return me some boolean value, right? Some boolean value. And what it is expecting, the second parameter is expecting one out mutex, right? So in this case what it is trying to do is it is trying to open this mutex instance, right? And if that mutex instance is available, right? If that mutex instance is already created, then that instance will be stored inside this mutex variable. And in this case, it is going to return me true, right? So you have to write the code which you want to access. If it is not returning true, means this instance is not created, then in that case, you need to create the instance like this. Right? So these are the two different versions of open in try open existing, and you can say open existing. Open existing means it will try to open one existing instance of the mutex, right? Whose name you need to provide. If that is available, it is going to return one instance. Right? If it is not available, then it is going to throw me one error. And coming to this try open existing, in this case, you need to pass two parameters. First is the name of the instance that you want to open, and the second is the out parameter where you need to store the mutex object, right? And in this case, if that instance is already created and available, then it is going to return me true. If that is not available, then in that case it is going to return me false, like the way try enter, try parse, try open existing. So whenever you see this try word in any of the existing method, then you will see that this method definitely taking one output parameter, and the return type of that method definitely going to be a boolean type, which indicates that whether it is successfully performed the operation or not. If it is successfully performed the operation, then it is going to return me true, and if it is not successful, then it is going to return me false. And in the case of a successful operation, the output, the result will be stored inside the out variable. Clear or not, guys?
Yes.
Okay. And apart from that, there is a method called release mutex. See, in this case, it will acquire the mutex, right? When you call the wait one method, right? On the mutex object, when you call the wait one method, right? Suppose I'm calling the wait one method, right? So in this case, it will acquire the log. And to release the log, what you need to do? You need to call the release mutex, right? So these are the methods that you need to that we are going to use, right? To create an instance, you have to use this syntax, but to check whether the instance is already existing or not, you have to use this try open existing or open existing, right? And to acquire the lock, you need to use this wait one method. And to release the lock, you have to use this release mutex method, right? Now, let us see some examples so that you will get some better clarity. Right. So in this case, you can see I'm creating 5 threads, right? I'm using the for loop to create 5 threads, right? And each time I'm calling the thread name as thread.i, and I'm just calling the start thread. So this is nothing but I'm creating 5 threads and executing those 5 threads. And all these 5 threads are pointing to this mutex demo method. Is there any question related to this main method code? Any doubt related to this one? What I'm doing here, I'm just using one for loop that will execute for 5 times, and each time I'm creating a new thread object, and that thread is going to call this mutex demo method. That means we are calling this mutex demo using 5 different threads. Clear or not? Any question related to this main method code? Guys?
No questions.
Yeah. So, and you can see here, I'm creating one instance of a Mutex class. Which constructor I'm using? The parameterless constructor, right? So you can see this is the constructor. Now the important information is this one, right? Okay. So in this case, the thread wants to enter into the critical section for processing, right? All the 5 threads can execute this statement because this is not part of our critical section code, right? All the 5 threads can execute this piece of information simultaneously, right? And then what I'm trying to do, I'm calling which method? Wait one method. What this wait one method will do? It will block the current thread until the current one method receives a signal. Wait until it is safe to enter, right? So that means what? Now, when you call this wait one method, it will block the current thread. Suppose you are invoking the 5 threads, right? All the 5 threads will invoke this wait one method, right? But all the 5 threads will not execute this piece of information, right? What they are going to do is only one thread will enter into the critical section. That thread will process, and that thread will exit, and then that thread will release the mutex object. Then only the next thread is going to execute the critical section of the code, right? So in this case, this is the way of creating the mutex object, and this is the way you can acquire the log, right? And this mutex.wait1 will ensure that only one thread will execute the critical section code, and at the time all other thread will block until they receive a signal, right? Until when they will receive a signal, the current thread will release the mutex object. And how the thread how the thread is going to release the mutex? By calling the release mutex method. So once this release mutex method is invoked, then other threads which are there in the waiting list, right, they will get a chance to execute the critical section of code. The same process, the same way we are using the lock and monitor, the same process it is going to use, right? Now, if you run the application, right? Now, let's run the application and see the output. See, you can see thread 1 enter the critical section for processing, and thread 1 processing now. And then you can see thread 2, thread 3, thread 4, thread 5. All are executing this code or not? Yes, all are executing this code because this is not part of your critical section. Then thread 1 started processing, thread 1 here completed. Thread 1 is completed its stuff, right? Once thread 1 is completed, then thread 4 get a chance. See, in this case, you cannot predict LIFO, FIFO, any principle is not applicable where. Here, processor or operating system randomly choose one of the thread to enter into the critical section. See here, thread 1, 2, 3, 4, 5. In this order, they are entering into the method, but the order of execution is first thread 1 get a chance to process or acquire the log and process. Then then not thread 2, then thread 4 is processing. After thread 4 complete its charge, then thread 5 processing, then thread 2, then thread 3, then thread 2. So you cannot predict the order, right? Order you cannot predict. That will be basically decided by the operating system which thread will going to execute, right? But in this case, you can see only one thread will get a chance to execute the critical section of your code. Clear or doubt? Guys?
Yes, sir, clear. This is for the internal threads, right? The
Yes, yes.
one.
This is for internal. External thread we have already discussed now. I will
Like,
come to
can't
that. Sorry, this is, see, whatever functionality you achieve using log and monitor, that you can achieve using Mutex also. But using Mutex, what you can achieve that limitation of external thread. Only one thread can execute, only one thread can execute your application code. That is what we have already discussed, or we have already seen in the first example. That is external thread. In this case, this is internal threads.
So my question, like, can't we use just like this, like mutex dot wait one and rest of the execution of our program in the main process? Can't we use like just
So
like this?
see, if you are going to use main process, right? So main process means what? You want to execute this code within the main thread only, right?
I mean, like for the external processes which are appearing,
Right.
the previously
See.
discussed one.
Right. First of all, tell me uh, why I'm going to invoke this. So who is invoking this mutex method?
Yeah,
That
here
is
in
for
this case,
internal thread, nah?
internal threads, yes.
Right? But if you want, then you can also put this thing directly inside the main thread. But in that case, this for loop is not going to be work now. In that case, you
Yeah.
have to execute that method 5 times.
Yes, yes, sir. I mean, like what I'm asking is like, when we restrict the external threads, we can, like what you showed previously, like using false and true parameters. Instead of that, just like this, like what you are doing in mutex demo class method, you can just copy and paste in main, and will it work there directly? Like,
So you mean you want this one?
yeah.
Okay.
No, no, not here. Not in this class. The one that you executed previously. External threads.
Yeah. So that is what I'm trying to do now. So this is what you are trying to tell me, right? Mutex one, then you have to call this and this is right. This is the things that we have done, or anything else. In the previous example, we are using some additional parameter, but the overall idea is this one.
Okay, if you paste that in
But
main,
in this case,
then it will restrict.
yes.
Yes.
So but in this case, what will happen? See, restricting the external thread, right? That is not that important, because if you are developing any kind of web application or any kind of a complicated application, then there is no restriction on the external thread, right? Anyone can access. So our main objective is internal thread. How we are going to manage the internal thread? Restricting to the external thread, we have already seen. Again, I'm also going to show you another example using the external thread, right? And in that example, I'm going to use this method open existing, try open existing, right? So, but what I want to make you understand is you have not only you can manage the external thread using this mutex class, you can also manage the internal thread using the mutex class. So for this example purpose is to manage the internal thread using the monitor using the mutex class. Even you can also manage the external thread using the monitor class. Sorry, using the mutex class. Using mutex class, you can manage both internal as well as external threads. That is what I'm trying to explain. Right?
Okay, so if we are calling it internally, it will act as internal thread. If we are calling outside as a main thread, then it will restrict the main threads.
Right.
That's the
So what I'm trying to do, make you understand is This kind of example we have already seen using log and a monitor. The same example you can also implement it using this mutex also, right? Coming to your point, now we will see another example, right, where you will understand that external thread concept, right? Right. So already we have seen that how to restrict the external thread, right? Do I need to explain how to restrict the external thread once more? Already we have seen now.
But this if condition is confusing a little bit. I'm not sure.
So
mutex.wait one, you are negating it, and then
see, you have to write some sort of logic to exit your application now. If you are not exiting, if you are not writing code, then how you will handle this? So in this case, okay, let me copy this one, right? So in this case, let me create this object separately, right? I'm creating this object separately, the way we are creating, and here, uh, right? Why I'm getting this? Right. So you are talking like this, right?
yeah, some sort of.
This is what we have written, right? So in this case, if you are not writing any if else condition, right, then how you can show that code? What is the build error? Type your namespace definition and with a file expected. Okay, right. Let me build the solution. See, application is running. Why it is returning? Because here we have only written this statement, right? After 5 seconds, it is returning me false, right? After 5 seconds, it is returning me false. But do we have any condition to close the application? You understood why I'm writing if condition? If you are suppose I'm writing this if this is going to return me true, right, then only I need to execute this piece of information, right? And else what I need to write, I need to write
Sir, after 5 seconds, it will be false, means after 5 seconds, another thread can execute our program.
no. So after 5 seconds it is returning me false. Why? Because when we execute the application for the first time, one external thread access our application code, right?
Yes.
But that external thread, we have not written any kind of logic to release the thread. Right? That means that thread is already in running mode. So as soon as that thread is not released, then it will not allow further thread to execute the application code. Right? This is the reason why this wait one method is going to return me false. So in this case, you can see I'm writing this return statement, and you can see. Right. So in this case, after 5 seconds, you will see that application is terminated. Okay. See, after 5 seconds, it will give you application is terminated. After 5 seconds, application is terminated or not? See, currently this one is running, right? And after 5 seconds, see this one. After 5 seconds, this window will be closed,
Yes, yes.
right? But to show you that message, what I write, I just put this message or put this statement, right? So I just put this statement before terminating the application. So this is the reason why you can see the output. So application is running, and now if you run this after 5 seconds, it will show you application is terminated. Then I just write the console.read line. That's why you can see it is expecting one input from the user, and as soon as I press anything, the application is terminated.
Okay.
Right? They provide you the option. Okay, if one thread is currently executing, for that thread, this wait one method is going to return you true, right? If that thread is not released, and if another external thread trying to access the code, then for that external thread, this method is going to return you false. Now it is up to you what you want to do. Whether you want to continue your application execution or you want to restrict the application execution, that logic you have to write. Right? But that condition, right, that Mutex class providing you. You have now two options. You want to continue, continue. You don't want to continue, then don't continue.
So
Sir,
wait is for waiting threads.
No,
Wait
no.
one is
Wait one is basically what exactly this thread is going to return means. It is not like wait one, right? It is going to block the current thread, right? It is going to block the current thread for how many milliseconds? For this many milliseconds, right? Within this milliseconds, if it is getting a chance to acquire a lock, then this method is going to return you true. If it is not get a chance to acquire a lock within this 500 milliseconds, then this method is going to return me false. And in that case, it is going to, now once it is returning me false, then this else part is going to be executed. And in the else part, we are writing this logic.
sir, whatever, like you are returning something in the else part, is that a mutex object that you are returning, or what is it return?
So you just tell me why we are using the return keyword inside a method. So if you
Keyword,
want to return something from a method, then you have to write the return statement or not.
but to whom it is returning? Okay.
Exactly. In this case, who is calling your main method?
Okay, the external thread
The
that it is.
operating system only, no?
I mean, like what return indicates is it indicates the mutex object only, no?
No. To why it is going to return? Do I have written mutex here? I'm not. So return with semicolon means it is only going to return from this method without returning any value, right? You are going to market. If you want, you can buy some fruits and come back to your home. If you don't want, just go to the market and return to your home. So in this case, the return statement is doing the same thing. It is going to the market without buying anything, just returning. And if you want to return something, then some data, then you have to mention that return. For example, so in this case,
But
right?
else method, even though if we don't mention return, it will come to the read key, no? The next statement. Why? What is the necessity?
But in this case, it will suppose in this case I'm writing some other statement, right? Some integer variable declaration I'm writing here. Integer x equals to 10, right? Integer y equals to 20, right? I'm calling some method here, right? Let me create some static void some method, right? And within this some method, right? I'm writing some logic also. Right? And I'm just calling this some method from here also, right? So if I'm not writing the return statement here, then it will not return from this statement. So it will execute this statement also, right? So in this case, if I commented this one, right, then what exactly this return statement means, from here only you need to return. If I'm commenting this, then it will come to this statement, it will execute this for statement, and then it will execute this statement, and here it will return. But once I write the return statement here, then this statement once execute, it will skip the execution of this statement and directly come to this part.
Okay, you are purposefully returning the control to end by
Exactly,
writing.
because purposeful means it is that is what our main agenda na. If one thread is running, one external thread is running, if another external thread trying to run our application, then we do not want that thread to execute our application code, and for that reason purposefully I'm writing this return statement.
Yeah, so this return will only return the next thread which is running. So I don't want to
Sorry, next thread which is running means.
I mean, like first thread which is acquired, it is executing, the application is running, and the next thread which is coming, it'll take that to else part, and it will return that part, and it will not allow the next the other thread to execute all our
So
code.
there is no relation between the current thread and the other thread. So first thread is running your application. Suppose you are so you are calling 3 threads. Second thread will come here, and second thread will not get a chance, right, to acquire a log. So it will come to the else part and it simply return. The second thread doesn't know whether there is a thread 3, thread 4, thread 5. It simply know that one thread is currently executing the application code. That is the reason why I'm not able to acquire the log. So I'm simply returning from this.
Yeah, I mean, rest of all the threads apart from the thread which is
Don't
executing,
don't mix with one thread with the rest of all thread. There is no relation between this thread and the rest of the all thread. It might be possible that thread 1 is running our application code. Thread 2 will not get a chance to execute the application code, so it will come to the else part. And meanwhile, thread 1 completes their execution and release the log. But for thread 2, it is returning from here. But thread 3, when will execute this one method, you will get a chance to execute this code, right? So don't mix up with the one thread with another thread. Simply speaking, when one thread is executing the application code, whether he acquired the log or not, he doesn't know whether there are 2 thread, 5 thread, or 10 thread are in the waiting list. He only know about himself that I'm going to execute the application code, and how I'm going to execute the application code if I acquire a lock, right? And and when I'm going to acquire a lock, if no other thread acquire a lock, if any other thread acquired a lock, then simply this wait one method will wait for 5 seconds or whatever time you have specified. Within that time period, if it acquired the lock, then it is well and fine. Else it will come to the expert and it will terminate the thread execution. That's it. There is no relation between this thread and the next and upcoming threads.
so then, like, for the first thread which is executing, how much time it will execute? I mean, like, when it will terminate, how we decide that?
As long as you are not releasing the thread.
Okay. I mean, like, when we're running the application using that executable file, till we close that, the thread is running.
No. Till you not close that. Once you close that, by default, the thread is going to be closed, right? Any application you run, and once you stop that application, the thread is going to be closed. But practically also you can release the thread. Na? See, in this case, which object is used to release the thread, or which method is used to release the mutex object?
Okay.
Release
I mean, like, in that
in this
loop,
case,
if
what
we
I'm trying to do is, right, I'm using thread dot sleep, right, thread dot sleep for 5 seconds, right, thread dot sleep for 5 seconds. I'm just commenting this one. So what I'm trying to do is, I'm going to execute the exe 2 times immediately, and after 5 times I will execute the exe once more, right? So in this case, okay, so I missed something. Mutex dot release mutex. Right. First time I'm clicking on the exe file, one external thread is going to run our application code. Second time I'm clicking on the exe file, another external thread is executing. So in this case, you can see both are running. Why? Because in this case, this thread is released. So what I'm going to do, instead of 5 seconds, let me put this as 1000 milliseconds, because in 5 milliseconds it will get this long, right? Application is running. See, one is application is running and this is application is terminated. So after 10 seconds, this first thread which is running your application, he will release the log, right? Now already we have surfaced the 10 seconds time period. Now I'm going to execute the exe once more. See, in this time I'm getting application is running. So basically what you need to understand is, now as long as your thread is not released, if another thread trying to acquire a log, then you will wait for the time period what you have specified. Within that time period, if he is able to acquire a log, then he will continue its execution. Otherwise, he will terminate it. So in this case, thread 1 is executing your application code, and thread 2 is terminated, and thread 3 or external thread 3 is able to run your application code, because while you are executing the thread 3, I mean while you are executing the exe third time, at that time thread 1 already released the log. You understood?
Yeah, perfect.
Fine. Any question from anyone?
Sir, just for clarification, thread 3 also wait for 5 seconds and then it will.
No, you are wrong. So thread 3 will wait for 5 seconds to acquire a log. But
Yes.
if before 5 seconds it acquired a log, then that is well and fine. In
Okay.
1 second it acquired a log, then continue its execution. It will not wait for 5 seconds. If he is unable to get a log, then he will wait maximum 5 seconds. After 5 seconds, it will return false. But in 1 second or some millisecond, it acquired a log, it will get return true and it will continue its execution.
Okay.
Clear, guys?
Yes.
Yes.
Okay.
Yes, sir. Clear.
Right now we are going to discuss another example, right? Another example in the sense using the other overloaded versions. So we have discussed the open existing, try open existing. That is what we are going to discuss. So in this case, I'm creating one static variable mutex, right, object, and I'm using this main method to create 3 threads, and all these 3 threads are going to invoke this mutex demo method, right? And here you can see all the thread trying to enter into the critical section, and here I'm writing mutex.wait1 method 100 milliseconds. That means what? Now each thread will wait 100 milliseconds to acquire a lock, right? And if they are able to acquire a lock, then they will come inside and execute this try block, right? And after executing the try block, they will release the mutex, and then so that the other thread will get a chance to acquire a lock, right? And in this case, if in 1 second, if the thread is unable to acquire a lock, then this else part is going to be executed, right? And then in the destructor, what I'm trying to do is I'm calling the dispatch method. How I am calling the dispatch method? Because if you go to the definition, this mutex class is inherited from wait handle abstract class, and this wait handle abstract class implement the iDisposable interface, and this iDisposable interface having this dispatch method, right? So I'm simply calling that a dispatch method on the mutex object to destroy the object, right? So the code is very straightforward. What we have discussed so far, the same code is written here, right? In that case, we are using we are handling the external thread, and in this case, we are handling the internal thread, but the logic is going to be same, right? In 1 millisecond, in 1 second, if the thread acquire a lock, then it will come and execute this statement. In 1 second, if the thread unable to acquire a lock, then it will come and execute the else part and will not acquire the mutex, right? Now, if you run the application, then you will see that say thread 1 processing, thread 2 and thread 3 will not acquire the mutex, right? So in this case, only one thread able to execute the application code while other two threads unable to acquire the lock. Now, if I'm putting this as a 200 milliseconds and if I'm putting this as a 300 milliseconds, then you will see a different output. Will not acquire the mutex, will not acquire the mutex because this thread, right, it is taking 300 milliseconds, right, to complete the execution. And what time interval we have provided here? 200 milliseconds. So in 200 milliseconds, the thread which is currently executing your application code is unable to complete its execution. So he is not releasing the mutex object. So other threads which are waiting in the queue, they will return what they will return. They will return false, and in that case, else part is going to be executed. Is that clear? This is the same example as the previous one. In previous example, we are managing external threads, right? And in this case, we are managing the internal threads. We are providing some time period. Within that time period, if the thread is able to, whether it is, in this case, if the internal thread is able to acquire a lock, then it will execute, else it will simply come out. And in the previous example, we are doing the same thing with the external threads, right? Now we are going to discuss one more example using the other overloaded version which we have discussed, right? That open existing, right? So this is my main method. So I'm creating one mutex class, variable mutex, and and in this case, what I'm trying to do is I'm trying to open one instance. I'm trying to open one instance whose name is my mutex. If first time if you are running your application, then there is no my mutex. So in this case, it is going to throw you some exception. If it is throwing an exception, then this generic catch block is going to handle that exception. So you can write catch block like this, and even if you want, you can also like this. So we have discussed both are going to be handled any kind of a exception thrown by the corresponding try block. So in this case, once the exception is thrown, then it will come to the catch block, and from the catch block, what it is going to do, it is going to create an instance of the mutex object, right? And in this case, I'm passing it true. True means the current instance, the current thread is going to be the owner of the mutex, and I'm providing the name, and here I'm returning it, right? And if more than one thread trying to access, in that case, I'm going to return this false, right? And in this case, from the main method, I'm calling this each singleton instance. Each singleton instance means first time you are calling application, first time you are coming to here, first time it is going to invoke this one, mutex.open existing. So it is first time. So this instance is not yet created. So it will throw the exception. So it will come to the catch block. And from the catch block, it is going to create an instance of the mutex object, and it is going to return me tree. As it is going to return me true, so in that case, I can make sure that more than one instance, right? Sorry, in that case, if it is returning true, so we have to write this statement. Okay, let me change that so that you will get better idea. Instead of using that not operator, I can simply do this, right? If it is a first instance, then you can see console.writeLine line one instance, and you can continue your program. Second time that instance is running, right? Second time you are invoking the exe file. Second time you are invoking this exe file, then it will come to this part. Again, it is trying to open this existing instance. Yes, this instance already created by the previous thread. So I'm not going to create, if the instance is already created, then in that case, it is not going to throw me any kind of a exception. If the exception is not thrown, then the catch block is not going to be executed. But after the statement which are present, after all the catch block, that statement is going to be executed. So in this case, it is going to return me false. So if it is going to return me false, then the else part is going to be executed and it will tell me that more than one instance, right? So that means what? Now, if I'm running for the first time, right, then you will see that it is going to return me one instance, and for subsequent call, right, it is going to return me more than one instance. Clear or not? And you can also do the same thing using the try open existing method. Right? That is a task for you. Try to use the other version, which is a try open existing, and just share your code in the Telegram so that I will check and verify how to use try open existing. So in this example, I have shown you open existing. I have shown you this Mutex class, and this try open existing. This is a task to you, right? And then I have shown you this, and these two are never used, right? So any question related to this Mutex class? Guys?
Sir, like, do we use this mutex in our real-time applications? Or-
See, if you are working with any kind of web application, right, then the use of this Mutex class is not there. But if you are developing some kind of a desktop application, then there might be a chance to use this one. Because suppose you are developing one desktop application, right, and you are providing the exe file to your client, and the client usually buy 5 license. That means the client wants that application to be used by 5 different machines, right? Then in that case, so you need to design your application in such a way that it is going to allow you 5 instances, right? That is what we have not yet discussed. That is what we are going to discuss after this Mutex class, right? But if the client only buy only one, the client only want so that you develop one application, and that application is going to be that desktop application is going to be used by the client in a single machine. He then in that case you need to use this mutex class. And if the client trying to use the same application in multiple machines, then only one machine is going to be work. All other machines at the same time they cannot use that application in multiple machines, right? So think you can take another example. Suppose you are creating your Zoom credential on Zoom credential. So while you are creating the Zoom credential, so you generally buy the license, right? If you are buying the license for one user, then at the same time, can you schedule multiple meetings, right? Or you can take the example of your antivirus. In your machine, you are installing antivirus. For the antivirus, you might be buy one license or 3 license. If you are buying one license, then once you use that license, can you use that license in other machines?
No.
But if you are buying license for antivirus with 3 users, then you can use the license in 3 different machines or not. In this case, we are only using the Mutex class, which only restrict us to a single instance, right? Which will allow only one external thread to execute our application code. But the problem with this Mutex class is that it will not allow us to control the overall experience, right? Control the number of external thread to access our application code, right? In this case, it is going to allow only one external thread. But if you want to allow multiple external thread to access your application code, then in that case, what you need to do? You need to use the other class which is provided by the system threading namespace, and that class is nothing but your Semaphore class. That is what we are going to discuss next, right? But before that, anybody having any question related to this one? Any more questions? Guys?
So, one more question, like the time that we specify wait time is to the waiting queue, correct?
No, not for the waiting queue, right? There is no such concept of waiting queue here. So you basically need to specify the time, and in that time, that current thread will block, right? And in that time, if he able to acquire the log, then he will continue its execution. Otherwise, he will not get a chance to execute, right? So in this case, you can see right. So in that case, you can see right. So in that case, we are specifying wait 1.100, right? So whenever you are specifying the 100 millisecond, 1000 millisecond means the current thread will blocked for 1000 milliseconds. Blocked in the sense it will wait for 1000 milliseconds, and in that milliseconds, if he is able to accurate the log, then he will continue the execution. Otherwise, he will simply come out from the come out from the queue, right? In this case, there is the else part is going to be executed, and you will never execute these things, right? And if you go to the wait one method, right? So what is that? All is clearly saying block the current thread until the current threading that wait receives a signal, right? That means as long as if within this time period, if he is unable to receive a signal, then he will simply come out from the execution, and you can use this overloaded option, right? So instead of this wait one, you can use this one also. So in this case, there is no time duration, right? And in this case, you will see that all the threads, right? All the threads will get a chance to execute the code, right? Right. So in this case, you can see all the threads are going to process the right processing, because there is no time limitation, right? They can wait till they get a chance to execute the code, right? But if you are specifying the time period here, right, then they will wait for that time period only. Once that time period elapses, right, they will come out, right? Understood or not?
Yes, yes, I got. Like there, like if the thread is sleeping for more than the mutex wait time, then other threads which are hitting that will not get the chance. If it is less than that, then they will get,
So
they
you,
may get chance.
okay, you just tell me why you are thinking about other threads. Why you are talking about always other threads, right? If
Means
there are only two threads, one thread, first thread is executing the application code, then second thread will wait for 1000 milliseconds. Why is there any other thread in the picture?
suppose there are more than two threads, they also will wait, no? Something like that.
Yeah, so one thread doesn't know about other thread activities now. If you are creating five threads, let's say thread one, thread two, thread three, thread four, thread five. Thread two doesn't know who is thread one, who is thread two, who is thread three, who is thread four, and who is thread five. Thread two only know about himself. He doesn't know about what other threads are there. He only think about himself. He only wait there until he get a chance to acquire a log. And within that time period, if he is able to get the log, then he will execute the code. And if he is unable to get a log within the 1000 millisecond, then he simply come out from the execution. So don't mix up with the other thread. Right? So in this case, it's possible that you are calling this thread simultaneously. It's possible that you are calling the thread in each 5-second time interval. That is also possible, right? So don't mix up with the current thread with the other threads, right? Yes, once as long as the current thread is executing, other thread will not get a chance to execute the critical section. But don't mix up other thread with other threads. He doesn't know. Suppose one thread is executing your application code. The first thread is executing your application code. The first thread doesn't know whether there are two thread, three thread, or 100 threads are in the waiting list. He have no idea about them. But what he knows, that thread knows as long as I am executing the critical section, no other thread can execute the critical section. But how many other threads are there, whether there are any other thread or not, that idea that thread doesn't have any, right? Understood or not?
Yes, yes, sir. Like I didn't mean that thread will be aware of other threads, but like suppose we are clicking 3 times the executable
See,
file,
if you are
then
clicking that, see,
we
if
are
you are,
aware that it is 3 times, 4 times. No, in that perspective, I was
no,
saying.
no, you are clicking 3 times, so you know that 3 threads are going to be there. But say,
Yeah,
one example I have shown you where I execute the exe file 3 times. Thread 1 is accessing the critical section. Thread 3 is terminating the execution. But thread 3 again accessing the critical section. That is also possible. How is that possible?
yeah, because it came out of that time, and again it is allowing other threads to
Obviously. So once,
ex
so simply speaking, when one thread trying to enter into the critical section, first of all, he needs to acquire or get a lock, right? Once he get the lock, then only he will able to enter the critical section. And when he will get the lock, if no other thread acquiring the lock, if any other thread acquiring the lock, and if that thread not release the lock, then no other thread can enter into the critical section.
yeah, got it.
Okay. Any more question from anyone else? Okay. The next important concept that what we are going to discuss is semaphore, right? See, before understanding what is semaphore class, let us first understand this question. Why do we need semaphore as we already have log monitor mutex in C#? So first of all, log and monitor, they are basically used to manage the internal threads. Even Mutex is also going to manage the internal thread, but for internal thread management, to manage internal thread, we generally use lock and monitor. But to manage the external thread, we use Mutex class, right? But using the Mutex class, we can only allow a single external thread to access our application. Using Mutex class, it is not possible to provide a 2 thread or 3 external thread to access our application code, right? But if you want to have more control over the number of external thread to access your application code, then you need to go with Semaphore class. See this example. This is your critical section, right? If you are using Mutex class, if multiple threads trying to access this critical section code, then only one thread can access your code, right? If you look at the Mutex class, then you will see. So this is the Mutex class, multiple external thread trying to access your application code, then only one thread can execute the code. But coming to Semaphore, multiple external thread trying to access your application code, and it is possible that you can decide the number of external thread can access your application code simultaneously, or right, same time you can allow one external thread, same time you can allow 2 external thread to access your application codes, same time you can allow any number of external thread to access your application code. So these things is not possible using this Mutex class. Clear? Why we need Semaphore and what is the problem with Mutex class? Using Mutex class, you cannot restrict the number of external thread to access your application code. You are using Mutex means only one thread can access your application code. And if you are using Semaphore, then what it means? It means you can restrict the number of external thread that can access your application code. You can restrict whether you want 2 threads, 3 threads, 5 threads, 10 threads, the number of threads to access your application code. Is that clear?
Yes.
Okay. Okay, let us directly jump to the example and try to understand this thing, right? And then I will explain you the code, right? So here I have written some piece of code, right? And you can see now what I'm trying to do is, so simply saying that while creating the semaphore object, right? Here you can see I'm specifying two. Two means for now you just consider, you just understand maximum 2 threads can access our application code at the same time, right? So let me, I will come to this code part. I will explain you the code, right? But for now, just remember the code, what we have written, it is going to allow me maximum 2 threads to execute our application code, right? I'm accessing, I'm using one external thread to access our application code. I'm using another thread to access our application code. I'm using another thread to access our application code. Now you can see, you can see. See? So the first thread, it occur, right? It trying to occur and it also occur. Occur means it occurred the lock and it is executing the critical section. Thread 2 also occurred the lock and the thread 2, right? The external thread 2 is also executing your application code. But when I click the exe file for the third time, you can see it is trying to occur the lock, but it is not get occurred and it is not executing our application code. That means if you give me 1 minute, guys. Right? So you can see the thread 3 or the third external thread is unable to execute our application. And if you want to restrict like this, then you need to use Semaphore class in C. Is that clear? Why we need Semaphore class? Right?
Yeah.
So basically, if you want to restrict the number of external thread to access your application code, then you need to use Semaphore. If someone asks you what is the difference between Mutex and Semaphore, then you need to tell. Mutex means only one external thread can access our application code. We do not have more control over the number of threads to access our application code using Mutex. But if we want more control over the number of threads that can access our application code, then in that case, we need to use Semaphore. Clear?
Sir, in this case, you are only restricting to 2. That is why it is executing for 2.
Exactly. Here, I told you now, here I'm writing some code. Here you can see 2, the second parameter. So this will allow maximum number of a thread to allow your application code. What is this parameter? What is all these things we are going to discuss. But for now, just remember, I just show you that maximum 2 threads can access our application code at the same time. And in this case, you can see 2 threads are accessing our application code. The third thread, while trying to access, is unable to access because already 2 threads are accessing our application code. Now, if I close one, right, and if I click on this again, right, so still it is not accessing. Why? Because we need to close all the threads, right? So yeah, so the way we have written the logic, it is not the proper way, right? So you can see it is not again when I'm closing one and when I'm clicking one more time, it is still not giving me the permission to access. Why? Because there is some mistake in the code that we can rectify, right? How we are going to rectify that I will show you, right? And once I will show you the Semaphore class in detail, right, then I will come to this example once more and I will show you this thing so that you will get better picture clarity, right? But for now, you just remember Semaphore means if you want to restrict the number of threads to access our application code, then you need to use Semaphore, right? So what is Semaphore? As we already discussed, Semaphore class is used to limit the number of external threads that can have access to a shared resource concurrently. In other words, we can say that Semaphore allows one or more external threads to enter into the critical section and execute the task concurrently with thread safety. So in real time, we need to use Semaphore when we have a limited number of resources and we want to limit the number of threads that can use. So guys, one more thing. I need to tell you that the number of threads that can simultaneously access your application code, that basically decided by your application CPU. So if you go to the task manager, if you click on performance and you click on CPU, you can see 4 core and a logical processor 8. This logical processor means this number of threads that can access your application code simultaneously, right? So logical processor 8 means 8 thread can access your application code simultaneously. That is what you need to remember, right? So for this four core means this is the physical processor on your machine, and this logical processor means this is the number of threads that can access your application code.
I mean, like application means all the applications which are
No, no,
installed on
for
our
each
machine.
application, for each application.
Okay, for each application, 8 simultaneous process can be allowed.
Eight
Is it?
simultaneously not process, 8 simultaneously threads. One
Yeah.
application means one process is there. One application cannot be accessed by multiple processes. In this case, you can say currently these are nothing but one application. For each application, one process. If I am executing the exe file one time, then you will see that exe file is loaded here. If I am executing the exe file another time, then you will see the exe file 2 times here. For each exe file, maximum 8 threads can access our application code in this case. Because why? Because the CPU what on my machine that allows only 8 logical processors. So in your machine, this core might be different. You might have a 2-core 6 logical processor, or some people are having 4-core 16 logical processor, right? That hardware configuration is basically decided by this is nothing but operating system point of view, and based on this logical processor, the number of a thread simultaneously can access your application. Right. So when we are going to discuss multi-threading, when we are going to discuss the concept called parallel programming, then at that time you will get a bigger picture clarity related to this.
So this thread means like these are external threads or internal threads?
These are internal threads only.
Okay.
See, whenever you are running your application means one external thread is going to run your application, and for internal thread, you can create any number of internal threads, right? But maximum 8 threads, they can access simultaneously your application code. And that maximum limit is going to be decided by this one, right? And if you want to check so this is decided by operating system. In my measure, in my code, how I can make sure that there are 8 threads, they can access my application code. Now there is something called one class called environment, right? Environment dot processor count, right? If you call this processor count method, right? This is the built-in class. Then you will see the number of logical processor that can access your application code, or you can say the number of threads that can access your application code. So in this case, it should give me 8, because in my machine, the number of a logical processor are 8. You can see it is giving me 8 or not, right? So if you are creating 100,000 10 thread or 15 thread, no matter, maximum 8 thread can access your application code. So in this example, right, in this example, the threads are going to be executed concurrently, right, one by one. But while we are going to discuss parallel programming, asynchronous programming, right, then at that time, right, then at that time you will see the real use of this processor, right? Parallel programming means parallelly 3 methods are going to be executed. How? Now each method is going to be executed at the same time by a different thread. If you are executing 10 methods parallelly, then out of 10 methods, only 8 methods are going to be executed at the same time. And once 2 methods completed, then another 2 methods are going to be executed. We'll see that practically once we discuss parallel programming. But just remember, the number of maximum threads that can access execute your application code is basically decided by this logical processor. So if your application is little bit slow, right, if you then you need to go to your server and you need to check the core and the logical processors, how many logical processors are there. So that basically decide how good your application performance is going to be, right? Okay, that is the secondary thing. Now we are going to keep focused on our Semaphore class. So if you go to the definition of Semaphore class, okay, let me type. Okay, if you go to the definition of Semaphore class, then you will see that the Semaphore class, it's a steel class and it is inherited from the wait handle method, right? And this wait handle method is an abstract class, and this wait handle method implement this iDisposable interface, and this wait handle method providing this dispatch method, and this wait handle method is going to provide some wait one method, right? That what we are going to use. Apart from this, this semaphore class is also providing some constructor, right? You can see 4 constructor semaphore taking some initial count parameter, some maximum count parameter, some new parameter, and some boolean created new parameter, right? And like the Mutex class, it is also providing some open existing method, try open existing method, and release method, right? So all these things what we have discussed in our Mutex class, the concept is going to be same. It is trying to open one existing semaphore object, right? If it is not available, then it is going to throw one exception. It is trying to open one existing semaphore object, right, using this try existing method, right? If it is able to access open that existing object, then that object will be stored inside this out variable, right? And that object name you need to specify in the first parameter, and in that case it is going to return me true. If that object is not created yet, right, then in that case it is going to return me false, right? And the same thing what we discussed with mutex object, the concept is going to be same. And this is release method and this is release count method. The same, the release mutex what we discussed, this is same. That means it is going to release the semaphore object. But here the interesting thing is how this semaphore object is work. That is what we need to understand. What is this initial count and what is this maximum count, right? And how this initial count and the maximum count is going to be work, right? So basically we need to understand these two parameters. Once you understand these two parameters, right, then you can easily understand the semaphore object and all these things, right? Right. So here you can see initial count parameter and it is a integer type variable, and the maximum count parameter, it is also integer variable, right? So what it actually going to do is the number of a maximum thread that can access your application code is going to be decided by this parameter. If I set this parameter to 5, that means the maximum number of threads that can access your application code is going to be 5. Clear or not? What is the use of this maximum count parameter?
Yes.
Right? But how you will decide, how the operating system decide how many threads are currently executing, whether I need to allow new more threads to execute your application code or not, right? How it is going to decide whether a new thread is added, new thread is released, right? That basically decided by the initial count parameter. Suppose I set this initial count parameter to 3, then what it means? It means so currently 2 threads are executing your application. Currently 2 threads are executing application code, right? Currently executing your application code, right? So understand. So how operating system decide that currently 2 threads are executing your application code means the maximum number of count is 5 minus the initial count is 3. That means currently 2 threads are executing your application code, right? Then suppose you one new thread come. If one new thread come, then what he will do? He will not do anything with this maximum count parameter. What he will do? He will reduce this count parameter, initial count parameter by 1. He will remove this initial count parameter by 1. If another new thread come, then what this value will become? This value become 2.
2.
Right? Suppose one thread release. If one thread release, then what it will do with this initial count parameter means it will add that value 1 to this initial count. So one thread release means what it will become? It will become 3. Right? And when this value becomes 0, right? When initial count parameter value becomes 0, what it means? Can anybody tell me how many threads are currently executing?
5 threads.
5 threads. That means if 5 threads are already executing in your application code, if any new thread is trying to execute your application code, then he will not allow. Then he will not allow to execute. He has to wait until one thread release the application, right? If that means if it, suppose currently 5 means let's assume that one new thread come. If one new thread come, then operating system will check this parameter. What is the value? The value is 0. 0 means no, you cannot, I cannot allow you to execute your application code, right? You cannot execute, you have to wait, right? And at some point of time, one thread release. If one thread release, then what this initial count parameter will become? Release means you have to remember
One.
then it will become 1, and once it become 1, then the new thread can execute, right? So this is the thing you have to remember. So the initial number of a request for the Semaphore object that can be granted concurrently, the maximum number of a request for the Semaphore object that can be granted concurrently, right? So this is the thing that you have to understand. So initial parameter value will decide how many threads are currently executing, and when this value becomes 0, then no more new thread can access your application code. Maximum thread will decide the maximum number of threads that can access your application. Clear or any doubt?
So this initial count will not directly indicate how many are threads are executing. It will
So,
give how many empty
this initial count, basically the maximum count minus the initial count is equals to the number of a thread currently executing your application.
Yeah, I mean initial count directly indicates that the one, suppose initial count equal to 1, then it will allow only one thread to execute.
Exactly.
Currently.
Exactly.
Okay.
And if its value becomes 0, means no more new thread can access your application code. If its value become 5, then you can allow, then it will allow 5 new more threads. But you cannot provide this value as 6.
Yes.
You provide 6, the maximum count is 5. Then how you can provide 6 threads to execute? So it will give you some kind of error, right? So you cannot provide this value greater than the maximum count, and you cannot set this maximum count as 0 or less than 0. It should be a positive integer number greater than 0. Understand or not?
Yes.
Now let us understand some examples so that you will get better clarity. Right? So you can see here I'm creating 2, 3. So 2, 3 means initial count. What is the, so even though you can also write like this. Initial count equals to 2, maximum count equals to 5. So you can also say if some method taking some parameter, you can also specify the name and the value by using a colon operator, right? So in this case, initial count equals to 2, maximum count equals to, let me give us a 3. That means what? Can anyone tell me how many maximum thread can execute our application code?
3.
And how many free slots are available? How many new
2.
threads? 2, right? And if I make this as 0, that means what? No more new thread can access your application. Right? Let me put this as a 2, right? And here, what I'm trying to do is I'm creating a for loop which will execute for 10 times, and I'm executing this do some task method using 10 different threads, right? And in this case, you can see what I'm trying to do is all the thread trying to enter into the critical section, but as we have restricted the number, as we have restricted maximum 3 threads, and the available thread is 2, so 2 thread can execute the application code simultaneously, right? So how you are going to provide? So first of all, you need to create the Semaphore object, and you have to call the wait one method and the thread which will get access, right? That thread will going to use this application code, right? And you can see once one thread acquire the lock, right? Then that initial count variable will be decreased by 1. And once you release the object, right? Once you release, then that initial count variable will be increased by 1. Any question from anyone?
Sir, one like doubt in that parameter. So you're using colon operator. So is
So
it
this
already?
basically say if you go to the definition of this class, so this is the first parameter, this is the second parameter, right? While you are creating a constructor or while you are calling a method, right? You can also specify the parameter name. If you do not specify this thing, then that is also fine. If you specify, that is fine. If you do not specify, then that is also fine.
Okay, that name is should be the parameter name what it is expecting, or
Exactly.
it can be any variable.
No. This should be the name as the parameter. It should be initial count and maximum count. You cannot provide any other name. You cannot provide XYZ. See, I'm providing XYZ. I'm getting error or not? If I'm providing
Okay.
initial count, I'm not getting any error. But if you are providing parameter name, then it is mandatory to provide parameter name, not rest of the parameter, right? So if you do not provide, then that is also fine.
Okay.
Right? So in this case, this is the syntax for creating the semaphore object, right? And this is the wait one method. This is provided by the this class. If you go to the wait handle class, then this wait handle class providing this wait one method, right? That is what we need to call to lock the resource, right? So it will acquire a lock, and once it acquire a lock, then what it will do? It will decrease the initial count variable by 1, right? That means this is the number of available slot is 2. That means 2 threads can simultaneously execute this application code, right? Once execute, then it has to release the lock, and once it release the lock, then again this initial count variable will increase by 1. So now if you run the application, then you will see that maximum 2 threads are going to access our application code simultaneously, right? So you can see 3 and 2 doing their work, 1 and 4 doing their work, right? And once 1 and 4 exit, then 2 new thread, 5 and 6 doing their work. And once 5 and 6 exit, then 7 and 8 doing their task, right? So this is how this is going to be work, right? That means what? Now at the same time, the maximum number of threads that can access your application code is 3. But as this application, there are only available 2 threads. So maximum 2 threads can access our application.
Sir, one doubt. Like, so we can initialize our initial to 0 now. Why we are initializing it to 2? Is that
See,
uh,
if you initialize this with 0, then tell me how many threads can access your application code. And currently, how many thread slots are available? Maximum
sorry?
count is 3.
Yeah, sorry. We can initialize it to three
Yeah,
itself.
you
So,
can initialize it with 3, no issue. If you
but
initialize with 3, then maximum 3 threads are going to execute your application.
I mean, like,
There is no
uh,
restriction. You can initialize with 1, 2, 3, any name. That there is no restriction that it should be 2 or it should be 3.
like, what is the
Right?
importance of this
See,
initial count? Like, uh,
see, basically what we generally do, integer uh, initial count equals to environment dot process count minus 1, right? And we generally use this one. So basically that basically decide in generally the number of a threads. What is this? This should be a starting, right? So basically what it should be that the number of threads available on your operating system minus 1 should be the initial count, right? If 8 threads are available, then it should be 7, right? So what the type is Okay. So can anybody tell me why I'm getting this error? By looking at the error message, what you can say? Does this error message gives you any information? The initial count for the semaphore must be greater than or equals to 0 and less than the maximum count.
Maximum.
So in this case, as in my machine, the number of processor is 8. So this initial count variable is going to be 7, 8 minus 1. So you are initializing it with 7 and you are allowing maximum to 3. Is that possible?
No.
No, this is the reason why it is throwing me some exception. So what I can do, I can put this as 10. So even I am putting this as 10, you can see 7 threads are doing the task simultaneously. And the rest 3 are going to do the task next. Clear? Hello, guys?
Yes, sir.
Yes, sir, clear.
So basically, now you can have control the number of threads that can execute your code simultaneously, right? So that is about our Semaphore class, right? Now in this case, you can see the previous example where we have discussed, right? They are unable to release the log, right? That is the why you are unable to access the code. But in this case, we are releasing the log, right? As we are releasing the log, then you can see after the number of threads, the new threads will get a chance. So currently 7 threads are doing their task. Once 3 threads free, see 1, 2, 3, then other threads start their work, right? So this is how the semaphore object is going to work, all right? Any question from the semaphore?
Sorry, sir, my system got hanged. I was not able to hear. My question was can we use all the 8 threads? Did you answer that question? I was not able to hear.
Yeah, you can use all the 8 thread. Yes, you can use all the 8 thread here. I'm using 8 threads. So now if you run the application, then you can see 8 threads are going to process your task simultaneously. See, thread 1, thread 2, 2, 1, 4, 5, 3, 6, 7, 8. 8 threads are doing their task. But generally, whenever we are working, we should not use all the process time, right? All the processors. So generally, we can use the maximum utilization, but not the all utilization, right? So you can see. So maximum thread is 8. So you should not use all the 8 logical processors. You can see the CPU time is higher. So you should use the ideal environment, right? As per my experience, you should use environment dot process count minus 1. So that 1 thread is available and the rest of the task is going to be done by this thread, because one main thread is there and all the child thread is going to do their task, right? But there is no restriction. If you use this one, then it is also fine. There is no issue. But you should not use the maximum threads that are available on your machine. And in real time, you do not know on your machine, you are having 8 core processor, 8 logical core. Some other machine, they might have 16 processors. Some other machine, they might have 4 processors, right? And if you hard coded this value, then at some point of time, then you will see that some error kind of environment, right? So it's always better to use this environment that process count, so that based on the operating system, the number of processors, it will give you the actual count. Clear?
Yeah, got it.
Okay. Any question from anyone? Okay. So in this case, so what is happening? Okay, in the next in our next session, we are going to discuss 2 important things. One is semaphore, and one is deadlock, because deadlock is very, very important. You might be know deadlock from your database point of view, right? Even when you are working with multi-threading application, then there might be a chance of a deadlock. So we'll discuss what is deadlock, how deadlock occur, how you can handle the deadlock, right? And before that, we'll discuss one small concept called Semaphore Slim. So you can consider this Semaphore class, and this Semaphore Slim is the lightweight version of the Semaphore class, and how to use and what is the use, that we'll discuss in our next session, right? And guys, tomorrow we have session. Tomorrow same time we are going to discuss these things. Okay.
And sir, I had one more question. Like this Semaphore is also like Mutex. It will handle both external threads and internal threads also.
Okay, so whenever it is handling external, means it is also going to handle the internal threads. But these things, how we are handling the internal threads, right? So this thing is not possible using the previous three things what we discussed: log, monitor, and mutex. Using this thing, you cannot write the code where more than one thread simultaneously access your application. This is not possible. This is only possible by using the Semaphore. Right? Using Semaphore, you can handle both external and internal threads, right? But if you only want to handle the internal thread, you are not interested with the Semaphore external thread, then in that case, you need to use Semaphore. That is what we are going to discuss tomorrow. See, why I'm discussing this? Because many people or many even experienced developer, they do not know this concept. There is a class called Semaphore. There is a class called Mutex. They do not know all these things, right? They want to know, they only know log and monitor. But apart from log and monitor, we are having many classes like Semaphore, Semaphore Slim, Mutex. Each classes have a separate functionality, right? Separate responsibility. And based on your responsibility, you need to decide what class you need to use. If you do not know that you can manage the number of internal threads to be executed simultaneously, then if you do not know this Semaphore class, then if you are using that monitor class and log class, then you cannot execute this critical section code by multiple threads. Right now, you understand that Semaphore class is there, and if I want to execute the critical section by multiple thread, I can do this. Right? Clear or not?
Yes, sir. It's clear.
Okay. So in the tomorrow we have session, and tomorrow we are going to discuss few more important concepts. One is this one, Semaphore Slim. This is not that important because you have already discussed this Semaphore class, means you can easily understand this. The important concept is deadlock. And after deadlock, we'll discuss a few more concepts. That is how multi-threaded application improve your performance, right? We'll do one measurement, right? We'll write some code using single thread application, and we'll write the same code using multi-threaded application, and then we will compare the performance. How much time the single thread application took to complete the execution, and at the same time, how much time the multi-threaded application took to complete the execution, right? And then we'll conclude that multi-threaded application is better in providing performance comparing to your single-threaded application, right? That's it for today. We'll meet tomorrow. Any question from anyone else?
No, sir. Thank you.
Okay. Thank you.
Thank you.